All right, in this video, I'm going to be continuing to work through some of the problems on the review for the Chapter 11 test, okay? So we're about to do some that deal with the square root method and also with the quadratic formula, okay? So these are problems from the Chapter 11 review still. Chapter 11 review, okay? And I was going to look at number 12 and number 13 that deal with simplifying radicals. So we have the square root of negative 272, and on 13, 16 plus or minus, actually, yeah, it did have plus or minus, square root of 80, all of that over 4, okay? So here, to use the square root method or the quadratic formula, you often have to simplify the radicals. So I wanted to make sure you were comfortable with that. All right, this negative right here should have made you think about how this problem is going to have an I in it. 272 is not real familiar, so you're going to work on breaking down. So this makes you think, I know I'm going to have an I. Then you just work on the 272. So I noticed it was even. I thought I would just go ahead and divide by 2, get it to be smaller numbers. I might even divide by 2 again. I think 68. Yep. All right, maybe 2 again gets me to 34, and 2 again gets me to 17. So 272 turned out to be 4 2s and a 17. So if I needed the square root of that, then I need a pair in order for it to be out of the radical. So square root of 4 would be 2, the square root of 4 would be 2, but this doesn't have a pair, so this right here would be left underneath. So I get 4 square root of 17, but remember this had a negative along with it. So that meant you actually have, when you see that, you really have the square root of -1 and then the square root of 272. So this we replace with an I, and then we have this 4 square root of 17, and it's just customary to write it. This part right here would be written 4I square root of 17, and then that negative is out in front of it all, and so that would be your final answer. And I need to see this. Okay, some of you have calculators that you really shouldn't be using for this test. You got to be showing me all your work. And in class, I'll just have you use one of my calculators if yours is one either I'm unfamiliar with. Okay, if your calculator does radicals, does the quadratic formula, has programming capabilities or graphing capabilities, then you can't use it. So you'll have to use mine. So you really ought to get yourself a basic scientific calculator like a TI-30 X2S. Okay. All right, so let's look at this one. Here we have we can't knock out the 4 into the 16 yet. Don't ever divide into that number under the radical. We just got to simplify square root of 80. So we're going to break it down. You might have noticed 8 and 10. Okay, this is 4 and 2. So this is 2 2s and another 2. 3 2s for the 8. 4 2s because of the 10. So we really get 4 2s and a 5. We're trying to do square root, pretty much like the other one. There's 2 pairs. So it'll be 2 times square root of 5. 4 square root of 5. That goes right there. And so what we have at this point is 16 plus or minus 4 square root of 5 all divided by 4. All right, now what we got to look for is whether we can simplify further, and we can because these all are divisible by 4. So we'll divide by 4 everywhere. 4 into 16 goes 4 times. 4 divided into 4 would be 1. So that'd be 1 square root of 5. 4 divided by 4 would be 1. And then if you divide by 1, okay, that's the same as the number itself. So there you have it. That would be your final answer on number 13. All right, so that skill is going to be used when you're solving using the square root property or when you're using the quadratic formula. So let's look at a couple problems here. All right, next one I wanted to look at was maybe number 15. 15 had m squared equals -20. All right, a lot of people miss this, and I don't know how I can get people to stop. Do you see how it's a squared? It should have 2 answers. Okay, so I'm doing this one because I just want to remind you, this one's missing the m term. So it is a good square root method problem, which means you need to get the thing that's being squared on a side by itself and then just take the square root. Okay, now when you do, you got to remember that every number has two square roots. Like 9 is both 3 times 3 or negative 3 times negative 3. 3 and negative 3 are the square roots of 9. All right, so the notation that I use, this symbol really only means the positive one. You need to get both the positive and the negative. So I've harped on that, hopefully until you're sick of me saying it, but then please make use of that. Make sure that you have it there because you need two answers to this question when you're finished. So when you do the square root of m squared, you'll get m. That's why you did what you did. And then this would be plus or minus the square root of negative 20. So we're going to think about that. So we have square root of negative 1 times square root of 20. 20 breaks down into 4 times 5. 4 happens to be a perfect square. You could stop there if you notice that and say 2 square root of 5 on that. Okay, or if you prefer, if you like breaking it all the way down, we were doing this, getting it to the prime factorization and then thinking square root and seeing that pair to get the 2 square root of 5. So either way you do that part is okay, either this or this. All right, then the square root of negative 1, that negative we saw tells us there's going to be an I. So this is 2i square root of 5. Okay, notice the plus or minus is in front of all of that. It's not in between the 2, the I, and the square root of 5. But you got to get both of those answers. Okay, and that's 15. You're finished on that one. All right, and then number 16 on this asked for you to solve, asked for you not to solve, but just to determine the discriminant. So it said something about finding the discriminant and then use it to determine the number and type of solutions. Okay. Determine whether you have, and the choices were 2 rational, then it said 1 rational, then it said 2 irrational, or 2, and it says non-real complex solutions. All right, that right there means imaginary. Okay, so all of that can be determined by just looking at what they call the discriminant. So what you got to do on this one is rearrange things a little bit because it's got to be equal to 0 so you can identify the A, the B, and the C. So you'll subtract the 7y and add the 4. You'll identify the A, the B, and the C. Okay, but instead of plugging into the whole entire quadratic formula, which, by the way, you got to know that, okay, you're going to just grab the discriminant. That's the discriminant. So you're going to grab that and just plug into it. So you're going to come over here, take your b squared minus 4ac. Place a b, you put negative 7. A was 4, c was 4. Okay, so that turns out to be 49, 1 minus sign, so that makes it negative. 16 times 4 is negative 64. And so that's going to wind up being negative 15. All right, and since it's a negative 15, since it's negative, I know under the radical I'll have a negative number, so that tells me I have 2 non-real complex solutions. Wouldn't have been factorable. I would have had to continue using the quadratic formula. Okay, the intent is not for you to go on and solve, though. All it said was to get the discriminant and use it to determine what type of solutions you get. And so this would be your answer right here. Okay. All right, and then we move into using the quadratic formula. Okay, so let's take a look at couple of those problems. So I thought I'd do a couple and then let you do a few. So let's look at 18. These say to solve using the quadratic formula. And that is what you're forced to do on those. So even if they factor, or even if a square root method would have worked, it's asking you to use the quadratic formula. So don't even think about the others. Don't have to waste any time even trying to factor. Oops, I don't want to do 19, I want to do 20. Okay. All right, so you want to work through the review completely and showing your work on all problems. Okay, so these say to solve using the quadratic formula. This one's already equal to 0. I'm going to identify my A, my B, and my C. I'm going to plug into the quadratic formula. The variable is an m, so that's what I'm finding is the value of m. So it's the opposite of b plus or minus b squared minus 4 times a times c over 2 times a. It's going to be negative 10 plus or minus. That's going to be 100 minus 24 all over 4. It was a minus because there was only one negative. That's negative 10 plus or minus square root of 76 over 4. And 76, need to break down. Let's see, 2 will go into it 38 times. So it's 2 2s and a 19. Okay, is that right? Yeah. All right, so if I do the square root of that, okay, there's a pair of 2s, and that pair of 2s would have been a perfect square of 4. So when you do square root of 4, you get 2. So you have 2 square root of 19, all of that divided by 4. Make sure that horizontal fraction bar goes underneath that negative 10. All right, and then we look at this point to see if we can simplify further. And because all of these 3 numbers are divisible by 2, I'm going to do that. I'm going to divide by 2 everywhere. So that'd be negative 5 plus or minus 1 square root of 19. I don't need to write that 1 right there. All divided by 2. And that's my final answer, except for I wouldn't have written the 1 right there. Let me take that back out. I would have just written that. Okay. All right, let's look at another one. This one you have a little more rearranging to do. So I would subtract the 5x, bring it over, but then I need to add the 5. Notice when it jumps across the equal sign, it's going to change the sign because I'm going to add the opposite to each of those. Now I'm going to identify my A, my B, and my C. Make sure if the value has a negative in front of it that you include that. Okay, so it's the opposite of B plus or minus. Take the B and square it. Minus the 4 times the A times the C. All of that over 2 times the A. Okay, so that's going to be a positive 5. This is a positive 4. And then underneath here, that negative 5 when it got squared is 25. And then this would be a minus because there's only one negative, and that would be 40. So I have 5 plus or minus the square root of negative 15 over 4. Okay. I'm thinking about that negative 15. I know the negative means it's going to have an I, because that's the square root of negative 1. So I'll replace that with I. But 15 only breaks down into 1, 3, and 1, 5. So there's not a whole lot I can do there. So my final answer will just be to bring the I out. Nothing goes into all 3 spots. This is my final answer on number 20. Number 20. Okay. So there's 2 where I used the quadratic formula. Okay. All right, I'm going to go ahead and do a few more on this. Okay, as you go to the next section on the test, it says solve using the method of your choice. And this was a question a couple students had. How do you know what method to use? what would be the best one. All right, so let's just look at a couple of them. All right, 23 is really weird, so I thought I would do 23. It's different from all the others. Okay. 24, I wanted to do, that one has 2n squared minus 56 equals 0. Then I thought we'd look at maybe 26. All right, and that one was 3x times x plus 1 equals 2. Okay, so with 23, you might think you would use the square root method, but you see how this has a y with it? You can't square root both sides right now because of that y that's on that right-hand side. So you really are going to have to get it equal to 0 by subtracting 9y. All right, when you do, you don't get 3 terms, you just have those 2. And I might try to factor this, but I thought it would be worth looking at that because, see, this just has a common factor of y. So when you factor that out, just turns out to be when you take out the y, there's a y minus 9 left. There's the times in between those two factors. So you set those equal to 0, and you get your two solutions, either y equals 0 or y equals 9. So there's your two answers to this one. Okay. All right, now look at 24 and 26. With 24, do you notice how there's no n term by itself? It's got a squared, it's got a constant, but it doesn't have an n by itself. This is missing that middle term. Okay. The b would equal 0 if I were to find it. That's the kind where I'm going to use the square root method. So that's going to be a square root method problem. That would be the most efficient thing to do. Okay, so if I'm going to use the square root method, that's the only one where you don't work on getting a 0. Instead, I'm going to add 56. Don't take the square root until you get the squared part of this by itself. So you have to get this by itself before you take the square root. So divide by 2. Okay, that's going to get you to n squared equaling 28. Now you take the square root of both sides. Don't forget to take both square roots. And you wind up with your n equaling positive or negative square root of 28. Now, square root of 28 has to be broken down. So you have to take the 28, think about breaking it down. I noticed 4 goes in it. So if I were doing it, I'd actually stop right there and say 2 squared is 7, because the 4 was a perfect square that just kind of jumped out at me. If you prefer that method, other method we looked at also works if you want to keep going until you get it to its prime factored step. Then when you do the square root, you're looking for a pair. If you have a pair, that means you can bring the 2 out and the 7 would be stuck underneath. All right, so your answer to this one turns out to be n equals plus or minus 2 square root of 7. Please don't forget the plus or minus. I am going to take off 2 points out of 4 if you do that. Okay, you've got to have 2 solutions. So don't forget about that. All right, and then see how this one worked well using the square root method? It's because it didn't have that middle term. Okay, now 26, initially, looks like somebody factored it. It would be wrong to set 3x equal to 2 and x plus 1 equal to 2. This would need to be a 0. Need 0 here. So before you do anything, you really need to fix this. Somebody factored before they should have. So you're going to do 3x times x, 3x times 1, and bring the 2 over. Okay? And then what you should do on one like this, there's going to be a lot that might have 3 terms like that. You should give factoring a quick try. I'm going to try 3x and x. My only choice is 2 and 1. No matter what I do, though, that would be 2x. That would be 3x. There's no way for me to get just 3x in the middle. So that tells me, well, I tried it, but factoring doesn't appear that it's going to work. Okay, so I'm going to go back and just use the quadratic formula. But square root method would not work well on this one because I have that middle term that has an x in it. So I'm going to let a equal 3, b equal 3, and c equals negative 2. The variable was x, so that's what I'm finding, what x equals. Be -3. I'm going into the quadratic formula, putting the b in there and squaring it, minus 4 times a times c all over 2 times the a. So that's -3 plus or minus. Got a 6 down here. Okay, under the radical, I have a 9, and then I have 2 negatives, so that's going to become a positive 24. Is that right? 9 plus, yep, that'll be 24. So that's going to be -3 plus or minus the square root of 33 all over 6. And then let's see, let's think about 33. Nope, breaks down only into 3 and 11, don't have any pairs. So this should be your final answer right here. There's not something you can knock out from here, and you should never go and try to cancel something under that radical. Okay, so your final answer, -3 plus or minus square root of 33 over 6. Okay. All right, so let me stop this video, and then I'll do all the applications in the next one. So let me stop this.